Today's lesson is 2.8. We're going to be talking about vertical angles and the transitive property. But before we start with vertical angles, we need to talk about two definitions here. Definition of opposite rays and the definition of vertical angles. The definition of opposite rays is two rays are opposite if and only if they are collinear, have the same endpoint, and point in opposite directions. All right. A picture representation would be if we had ray, let's say AB, and then we had ray AC. Those would be opposite rays of each other. Definition of vertical angles. Two angles are vertical if and only if their sides form two pairs of opposite rays. Okay, what does a picture look like there? Basically, what that looks like would be that you have these two would be vertical. 1 and 2 would be vertical. And then, let's change colors. And then we'd have 3 and 4 would also be vertical to each other. Gives you two pairs of opposite rays. So a quick representation. Let's say this angle was 30. The vertical angle of that would also be 30. You know, these are supplementary, so that means this would be 150, which means then this vertical angle here would be 150. That's the idea of these vertical angles. Okay. What does it look like to be a proof of vertical angles? Well, you're going to start out with your basic proof here, where let me give you a picture representation. So we have this picture, A, B, C, E, and then D. Let's call this angle 1, 2, and 3. So let's use this picture. So we know that ABC is a straight angle. We also know that angles 1 and angle 3 are adjacent. So we can say that angles 1 and 3 are supplementary. We also can say DBE is a straight angle, and angles 2 and 3 are adjacent. Same reason as above, angles 2 and angles 3 are supplementary. Look at that, they're sub to the same angle. So we haven't seen that reason in a while, so they're both sub to 3, so that means angle 1 is congruent to angle 2, which are your vertical angles, and we've just learned that the vertical angles are congruent. So reason 1 is if two adjacent angles form a straight angle, then sup, and reason 2 was sups of the same angle are congruent. What your shorthand is going to look like is that you're going to be able to put an arrow out and the reason and say that 1 is congruent to 2 and use it, and that reason is going to be vertical angles are congruent. All vertical angles are congruent. That's what it's going to look like in your proof that you're going to be able to use. Kind of just like that reflexive property. That's something that you're going to be able to use. But not only do you use that in proofs, you're also going to be using it without proofs. So like in questions where you're going to solve for x. So let's look at this example here. Find the measure of angle ABC. Well, ABC is right here. We don't know anything about it, but we know it's supplement to both of these two angles. And these two angles here are vertical angles, so they're congruent. So we can set x squared plus 2x minus 8 equals to 10x plus 40. What do you notice? That's correct, an x squared. So you notice an x squared, everything has to go over that side so that you end up having to be able to factor. So we're minusing 10x and we're minusing 40 over to this side to equal 0. So we get x squared looks like minus 8x minus 48 equaling to 0. This is what we need to factor. All right, it's got a leading coefficient of 1, so we could go right into x and x, two numbers that multiply to negative 48, but add to negative 8. It looks like we have negative 12 and positive 4. So this answer is 12. This answer is negative 4. Let's try it out. I always try the negative one first. So we got 10 times negative 4 plus 40. Well, that's negative 40 plus 40. That's 0. Can you have an angle measure of 0? So negative 4 doesn't work. 12 is the only one that works. We want to find angle ABC, so we'll plug it back in. 10 times 12 plus 40. We end with, this is 120 plus 40, so that's 160. So this angle measure is 160, which means this one has to be 160. So how much is it supplement? 20 is left over because you do 180 minus 160. So angle ABC equals 20 degrees. And you found your answer. We're done. For the proof, let's see what we have here. We know that angle 1 and 2 are congruent. And we're trying to prove 1 and 3 are congruent. So we look at the picture and we say, wait a second, 2 and 3 are what kind? 2 and 3 are vertical angles. So because they're vertical angles, we know 2 is then congruent to 3, which then makes 1 is congruent to 3. What does our proof look like? We got angles 1 congruent to angle 2. All right, to start out with. We also know that from the picture, reason 1, we can say angle 2 is going to be congruent to angle 3. If you need to, you could go from the diagram again. We want to rearrange these and use substitution, so we'll have to say angle 1 equal angle 2. Same reason, we can say angle 2 equals angle 3. Bracket them together. We're up to reason 3. Now angle 1 is equal to angle 3, which then we can say 1 is congruent to 3. Reasons, first one was all vertical, sorry, not all, vertical angles are congruent. 2, def of congruent. 3, substitution. And 4, definition of congruent once again. Now, are you getting tired of going from congruent to equals, using substitution, and then back to congruent? I know I am. So in this section in the book, they also talk about this idea called transitive. It is similar to substitution. The only difference is it allows to substitute congruent pieces in for other congruent pieces. What does that mean? Let's say we were using the proof above. We knew that angle 1 was congruent to angle 2. And then we had from the the picture that angle 2 was congruent to angle 3, or you could say from the diagram, whatever. Instead of saying the equals and substituting, what you can do is you can bracket these two together and go straight into saying that, hey, guess what? Angle 1 is congruent to angle 3 because these are the same angle here. So it's that idea of substitution, but you're not going to call it substitution. Reason 1 would have been the vertical angles, and then reason 2 is going to be your transitive property. So you can use transitive to go from congruent straight to congruent. This is what I would start using now. This is huge, the idea. I would start using this transitive idea here instead of going to equals and then substitution. So it works the same way, but you're allowed to go from congruent to congruent. I hope this lesson was easy and you were able to understand it. And good luck with the homework.